Here we have two grooved metal ramps and a steel ball. If the steel ball is given a nudge along this lower ramp, the second ramp, it moves at more or less a constant velocity across that ramp. The first ramp is inclined so that the ball accelerates down the ramp and onto the second. What we want to test is whether the final velocity on the first ramp is equal to double its average velocity when the ball is released from rest. We expect that if a ball is released from rest with initial velocity 0, then its velocity will go from 0 to some final velocity, and that the average velocity will be halfway between the initial and final, which is the half of the final velocity. Now, if the final velocity in this ramp is double the average velocity, then the average velocity on the second ramp, which is going to equal the final velocity in the first, ought to be twice as great as the average velocity on the first ramp. We can test this as follows. I'm going to put a soft drink can 10 units from the point where the two ramps meet. Then I'm going to release the ball using this 2x4 as a kind of a starter. I'm going to release the ball from this point by hitting the 2x4 with a 1 kilogram weight. Now listen to what you hear. You hear three sounds. You hear the knock of the weight on the wood block. You hear the sound of the ball going from the first ramp to the second, and you hear the clank of the ball as it hits the soft drink can. Now if, let's back up a second, I'm not sure I said it, the distance here is 10 centimeters, the distance here is 20. If the final velocity on the first ramp is double the average velocity, then the time on the second ramp should be the same as the time on the first. The reason being, if the final velocity is double the average, then the velocity in the second ramp will be twice as great as the velocity in the first, which means that in equal times the ball will roll twice as far in the second ramp as it does on the first. Now let's see to what extent that's true. I'm going to give you a count of 3, and I'm going to release this. And I want you to listen to see if you think the sounds are equally spaced. Okay, is there a steady rhythm to that? Is it clank or I don't know, what do you call that? Clunk, clank, clank, I don't know. Are those three sounds 1, 2, 3, or is the spacing between the sounds not uniform? Okay. Now this time I'm going to give you a count of 3, and what I want you to do is get yourself a pendulum, and you're going to try to synchronize the pendulum so that you release the pendulum, let's say at this position, when I give you the 3. The 1, 2, 3. On 3 I'll be hitting this, and you'll hear the clank or the clunk of the metal on the wood. Then, let's see if we can get it, the pendulum length, so that when the pendulum swings out and reaches its extreme position on this side, the ball is clanking from one ramp to the other. And then finally, let's see if on the return the pendulum doesn't reach its original position at the same time the ball hits the can. Okay, so let's try this and see. Ready? 1, 2, 3. Okay. I'm not sure it made any difference, but those ramps were a little offset. That might have affected the speed of the ball. So let's try again. Ready? 1, 2, 3. Okay? So, using a pendulum, test whether those sounds are equally spaced. If they are, you have a pretty good idea that the average velocity in the first ramp is half as great as the average on the second. And since the average velocity on the second is equal to the final velocity in the first, that's going to confirm our belief that the average velocity in the first is half of the final velocity on the first. I'm going to reset the system so that now the ball is going to go 20 centimeters on the first ramp and 40 centimeters on the second. Okay? I'm going to give you the 1, 2, 3, and let's see if you can synchronize a pendulum with this one. Of course, you might have to replay the video clip a few times to experiment with the synchronization, but here we go. Ready? 1, 2, 3. And let's run that one again just to make sure that everything's repeatable. Ready? 1, 2, 3.